Okay, so I want you to picture a scenario. It's one we've all been in.
Hmm.
You're sitting there, maybe holding your phone or, staring at a monitor, scrolling through a breaking news feed.
Yep, I'm there.
It could be anything. A sudden political scandal, the recap of a chaotic football game, reports on a natural disaster. You're scanning the text, barely even focusing on the individual words, but your brain is doing something incredible. It is. It's practically vibrating with activity. It's building a timeline.
It's an almost automatic cognitive process, isn't it? We don't even realize we're doing it.
Exactly.
Mm.
You know the scandal broke after the emails were leaked, but before the resignation. You know the touchdown happened during the rain delay. You don't need a calendar next to you. You don't need timestamps on every sentence.
Oh, I get it.
You just get it. You instinctively understand the flow.
We construct that narrative flow intuitively. We are wired for story.
But here's the hook, and this is where it gets really interesting for me. We aren't just doing that by looking at grammar or dates. We're doing it by feeling the story. We sense the panic before the resolution. We sense the anger before the apology. The emotional flow helps us build the time flow.
That's a really good way to put it. And it's also scientifically grounded, which brings us directly to the core of today's deep dive.
Right.
What if computers could do that? What if we could teach artificial intelligence to use sentiment feelings, essentially, to better understand time?
It sounds like a crossover between a sci-fi novel and a psychology textbook, but it's actually some very hard science. Today we're digging into a fascinating research paper titled Temporal Analysis and Visual Tracking of Sentiment Events.
This research comes to us from a cross-continental team. Dipankar Das, Anup Kumar Kolia, and Sivaji Bandyopadhyay from Jodhpur University in India, collaborating with Asif Iqbal from the University of Trento in Italy.
And our mission today is to unpack how they're training machines to stop looking at text as just dry data and start reading between the lines to find the emotional timestamp. Because, let's be honest, computers are usually pretty bad at understanding the vibe of a situation.
Well, they are. And this paper represents a significant shift in the field of natural language processing, or NLP. We're moving from the computer knowing what happened to understanding the emotional context of when it happened.
All right, let's get into it. Usually when we talk about NLP on these deep dives, we're talking about syntax, grammar, subject-verb agreement, all the dry stuff.
Right.
The stuff I hated in high school English class.
Usually, yes. Traditional NLP relies heavily on those structural rules. But these researchers had a different hypothesis. They believed that text contains something they call attitudinal private information.
Attitudinal private information. That sounds like something a lawyer would say to object in court.
It's a fancy academic term for emotions, opinions, and private states of mind. The researchers argued that events and sentiments are closely coupled. You can't really separate the event from how people feel about it.
Okay.
And their theory was, if a machine can identify that feeling, is it happy, sad, fearful? It might be better at guessing where that event sits on the timeline.
Okay, but before we get to the solution, which involves some pretty cool tech, we have to understand the problem. Why do computers struggle with time? I mean, computers are clocks. They should be perfect at time.
You'd think so.
But the paper references something called Task C of the Temp-Evil 2007 challenge.
Right. So Temp-Evil is this major competition in the NLP world where systems compete to see who can parse text the best. It's like the Olympics for text analysis algorithms.
And Task C is the hard one.
It's notoriously difficult.
Yeah.
The task is, well, it's identifying temporal relations between events in adjacent sentences. So imagine you have sentence A and sentence B sitting right next to each other. The computer has to make a decision. Does the event in sentence A happen before the event in sentence B? Does it happen after, or do they overlap?
To me, that sounds incredibly basic. I cracked the egg, I cooked the omelet. Cracking comes before cooking. Why does a supercomputer struggle with that?
Because you just used a logical sequence that implies cause and effect in a very obvious way. But real language it's messy, it's chaotic.
Sure.
Often there are no timestamps. There are no clear connecting words like before, after, or then. Writers just assume the reader is smart enough to fill in the blanks.
So the computer's just looking at two isolated verbs and trying to guess who went first.
Essentially, yes. It analyzes verb tense, grammatical structure, context.
Yeah.
But without those clear markers, computers often just guess vague.
Mm.
They can't figure it out.
And that's where the aha moment comes in for these researchers.
That's it.
They thought the vibe of the sentence could solve the puzzle.
Precisely. They proposed that if you look at the sentiment, it provides a logical structure that grammar misses.
The source material actually gives a really specific example of this, a story about a hijacking. I want to walk through this because when I read it, it clicked for me.
What?
This is the moment I realized why this research matters.
It's the perfect illustration. The text they analyze is, the Prime Minister of India told Friday that he has talked with top commander of Indian military force and sent a team to recover the host of Taj Hotel hijacked.
Okay, that is a mouthful. Let's break it down. We have three main events happening here. One, the hijacking of the hotel.
Right.
Two, the Prime Minister talking to the commander. And three, sending the team.
Now, as a human listener, you essentially know the timeline instantly.
Right. The hotel gets hijacked first. That's the problem. Then the PM talks to the commander to figure out what to do. Then, as a result, he sends the team. Hijack, then talk, then send.
Correct. But look at the syntax. Look at the word order.
Yeah.
The Prime Minister told that he has talked
Oh.
and sent a team to recover the host of Taj Hotel hijacked. The word hijacked appears at the very end of the sentence.
So a dumb computer relying on word order or basic grammar might think the hijacking happened last, just because it's the last word.
It's very possible. Or it might just get confused because the sending and the talking are mixed in there. There's no word because or after to help it.
The grammar doesn't explicitly state the order.
It doesn't. So how does sentiment fix this? The researchers argue that the emotional logic dictates the time. Hijacked carries a strong negative sentiment fear or negative polarity. Sent a team implies an action taken to resolve a situation.
So in our narrative logic, a problem, the negative sentiment usually precedes the solution.
Exactly.
That is fascinating. The machine isn't just reading the grammar, it's reading the drama. It says, oh, this is a crisis and this is the response, so the crisis must come first.
It uses the mood to structure the time. It recognizes that fear usually triggers action. It's utilizing the causal link between how we feel and what we do.
So to make this work, they can't just tell the computer read the room. They had to build a specific type of machine learning model. The paper mentions they used a CRF.
Yes, a conditional random field.
Now, without turning this into a math class, because I will fall asleep, what makes a CRF different from just a standard algorithm?
Think of standard algorithms as looking at snapshots. They look at one isolated thing and make a decision based only on that thing.
Okay.
A conditional random field is more like watching a movie. It's excellent for sequence labeling. It takes context into account. It looks at the neighbors of the data point it's analyzing.
So it doesn't just look at sentence B, it looks at sentence B given what we know about sentence A.
Exactly. It considers the dependencies. And the reason they chose CRF is that it avoids something called label bias, which is a technical way of saying it doesn't get stuck in a rut based on previous bad guesses.
Uh-huh.
But more importantly for this study, it allows the researchers to throw in an arbitrary set of features.
Meaning they can feed it whatever ingredients they want.
Yes. Most systems rely on what are called the gold standard time bank features. These are the meat and potatoes of NLP.
What's on that list? What does a standard robot look at?
Things like the event stem, the root of the verb, the string, the actual text, and tense and aspect.
Tense I get, past, present, future. That seems critical for time. But aspect always trips people up.
Aspect is just about the flow of the action. Is it progressive, like I was running, meaning it's ongoing? Or is it perfective, like I had run, meaning it's finished? These are the standard grammatical tools we use to tell time.
Okay, so those are the standard tools. The computer looks at the verb, checks if it's past tense, checks if it's finished. But these researchers added a secret sauce.
The sentiment features. This
Yes.
was their innovation. They added a new layer of data that the CRF had to look at before making a decision on the timeline.
And they broke this down into two types of sentiment, right? Coarse and
Right.
fine.
Coarse-grained sentiment is binary and simple. Is this event positive or negative? Is it good or bad?
That seems pretty broad. I dropped my ice cream as negative, but so is the world ended. Those are very different negatives.
Which is why they also used fine-grained sentiment. For this, they turned to psychology. They used Paul Ekman's 6 basic universal emotions.
Oh, I know these. These are the inside-out emotions.
Essentially, yes. Happiness, sadness, anger, fear, surprise, and disgust. Ekman argues these are biologically universal to all humans, so they make a great baseline for AI.
So the computer scans the text, it sees a word like celebrate and tags it happiness. It sees attack and tags it anger or fear. But wait, does the computer actually know what those words mean?
Not in the way we do. It doesn't feel the anger. They didn't sit there and manually tag every word in the dictionary either. That would take a lifetime.
Right.
They used existing computational tools, massive databases called SentiWordNet, WordNet Affect, and VerbNet.
How do those work?
They assign emotional scores to words. So, SentiWordNet might say the word love has a positive score of 0.8 and a negative score of 0.0.
Yeah.
The system pulls these scores to build a mathematical profile for every event in the sentence.
So we have this machine. It's looking at the grammar, the tense, the aspect, and now, thanks to this research, it's looking at whether the sentence is angry, fearful, or happy. The big question is, did it actually work? Did adding feelings make the computer smarter at telling time?
The short answer is yes.
Yeah.
It worked better than they even expected.
Better than the competition.
Significantly so. When they tested this system against the state-of-the-art systems from the Temporal 2007 challenge, their sentiment-aware system came out on top.
Let's look at the numbers. The paper mentions an F-score.
An F-score is a standard way to measure accuracy in machine learning. It balances precision, did you get it right? And recall, did you find all the answers you're supposed to find?
So it gives you a single number to judge performance.
It does.
And what did they score?
Under strict evaluation, meaning the computer had to get the relationship exactly right, they got an F-score of 57.2%.
I have to be honest. If I came home with a 57% on a test, my parents wouldn't be celebrating. Is that actually good?
In the context of school, no. But in the context of temporal relation extraction, that is actually very high. You have to remember, this is one of the hardest problems in AI. Humans even disagree on these timelines when reading complex texts.
So 57% is actually leading the pack.
It is. And when they used relaxed evaluation, which gives partial credit if the answer is close or overlaps, they hit 58.6%.
But here is my skepticism coming out. I'm always looking for the catch. How do we know it was the sentiment that helped? Maybe they just built a better CRF than the other guys.
That's the crucial question. And to prove it, the emotions doing the heavy lifting, they ran the test twice. This is standard scientific method. Once with just the standard grammar tools and once with the sentiment features added in. The sentiment features provided a clear boost. But what's really interesting is where it helped. It didn't just help everywhere equally. It specifically improved the computer's ability to understand subordinate events.
Explain that. What is a subordinate event?
These are events that are tucked inside a sentence, usually dominated by a main verb. For example, he regretted buying the car.
Okay. Regretted is the main event. Buying is the subordinate event.
Exactly. And these are notoriously hard to place on a timeline because they often lack their own time markers. The computer sees regretted is past tense, but when did the buying happen relative to the regret? Grammatically, it's ambiguous for a machine.
Well, logically, you have to buy it before you regret it. You can't regret a car you don't own.
Logical to you. But the computer needs a rule. The researchers found that adding sentiment improved the accuracy for these subordinate events by roughly 2 percentage points.
That's a solid bump in this field.
It is. It proves that sentiment isn't just flavor text. It's a structural feature. If regretted is negative and buying is the cause, the emotional logic helps the machine place buying strictly before regretting.
It's using the emotional consequence to deduce the cause. That is surprisingly human.
It really is.
So we've established that the computer can read the text, identify the emotions, and use them to build a timeline. But the paper title isn't just temporal analysis, it's temporal analysis and visual tracking.
Right.
They weren't satisfied with just a spreadsheet.
No, they didn't just want a list of data. They wanted to see the story. They wanted to visualize the narrative arc.
So they developed a visualization system. How did they do that?
They used something called an XML schema to generate directed graphs. Imagine a spider web of bubbles on a screen.
Walk us through it. What am I looking at if I'm looking at one of these graphs?
Each bubble or node represents an event from the text, the meeting, the attack, the celebration. And these bubbles are color-coded based on their emotion. Maybe fear is purple and happiness is yellow.
And the connections, the lines between them.
Those are arrows or edges connecting the bubbles. These arrows represent the timeline the computer figured out. An arrow pointing from the attack bubble to the fleeing bubble means the attack happened first.
The paper also mentions sentiment hubs. That sounds like a place I'd want to hang out if it was a happiness hub.
That's exactly what it is. In the visualization, they group events by emotion. So instead of a messy scatter plot, all the happy events link back to a central happiness hub. This allows you to glance at a document and immediately see the emotional density.
Is this a fear-heavy document? Or is it mostly surprise?
Exactly. It gives you an instant read.
That sounds incredibly useful for analyzing something like a political speech or a novel. You could see the dominant emotion instantly. But they also tracked how the mood changes, right? It has some specific terms for this.
They do. They talk about the sentiment twist.
The sentiment twist, it sounds like a bad dance move from the 60s.
It does. But here, a sentiment twist is the specific change in emotion between two consecutive events. So if event A is fear and event B, which happens right after, is relief, that specific shift is the twist.
And what if it's a longer chain, like event A leads to B, which leads to C?
They call that a sentiment transition. This tracks the emotional journey over 3 or 4 events. So you can see a character go from sadness to anger to surprise to relief.
Was the computer actually good at this, capturing the flow?
It was satisfactory. According to their manual evaluation, they checked it against 20 documents themselves. But it had quirks. It was much better at tracking course changes, like simply flipping from positive to negative, than it was at pinning down the specific shift from, say, sadness to disgust.
Where did it fail? What confuses an emotional AI?
Neutrality. The system really struggled to assign neutral tags to sentences that had implicit sentiments, but no obvious emotional words.
That makes sense.
Yeah.
I walked out the door, could be neutral, or it could be incredibly sad, depending on the context. If you just broke up with someone, walking out the door is tragic.
Precisely. The system struggles with that nuance, and it also struggled with reverse polarity.
Reverse polarity. That sounds like Star Trek.
Think of sarcasm, or a sentence with a big B-U-T in the middle. I was terrified, but then I realized it was just a cat. That rapid 180-degree turn where the second half of the sentence negates the emotion of the first half is very hard for a linear model to capture perfectly.
Sarcasm is hard enough for people on the internet, let alone a conditional random field algorithm. I misread sarcasm in texts from my friends half the time.
True. But despite those errors, the manual evaluation showed that it successfully mapped the mood flow. It got the gist of the story's emotional shape.
Mood flow. I like that term. It feels like we're moving away from treating text as just static data points and treating it as a living, breathing thing with a pulse.
That is the bigger picture here. We are moving beyond keyword search.
So I want to bring this back to the listener. Why does this matter? Maybe they aren't building an NLP engine in their garage. Why should they care about sentiment twists?
Think about the applications mentioned in the source, like mood views or theme river. This technology isn't just about parsing grammar for the sake of it. It's about analyzing massive amounts of data to understand public sentiment over time.
Like tracking the stock market.
Exactly. Or political campaigns.
Ah.
Imagine a tool that doesn't just tell you how many articles were written about a candidate, but graphs the emotional trajectory of those articles over a month.
So instead of just seeing a poll number go up or down, you see the narrative arc.
Right. Did the narrative shift from hope to disgust on a specific Tuesday? And critically, because of the temporal analysis, did that shift happen before or after a specific policy announcement?
That is incredibly powerful. You could track customer satisfaction with a product release, not just by star ratings, but by the sentiment transition in their reviews. I was excited. Future tense. I bought it. Past tense. I'm disappointed. Present tense.
Precisely. It gives us a way to quantify the qualitative experience of the world. It turns mood into a metric.
It's fascinating to think about. We started with a specific problem, teaching a computer to order events in a sentence, and we ended up with a tool that can map the emotional landscape of our stories.
And it validates something we've always known intuitively, even if we didn't have the math for it. Emotion isn't separate from logic. Emotion is a form of logic. It has a structure, a sequence, and a set of rules. This research proves that even for a machine, you can't fully understand the what and the when without the how it felt.
Here's a thought to leave you with. The source mentioned that their manual evaluation was satisfactory. The computer did a good job. We're getting to a point where computers can graph the emotional trajectory of a news story accurately.
Right.
So if AI can now read the news and feel the narrative arc, are we approaching a point where the AI actually understands the story better than we do?
I mean, we skim, we get distracted, we bring our own biases. The AI just sees the raw sentiment twist in the data.
That is a provocative thought. Does the machine see the emotional truth more clearly? Because it doesn't actually feel the emotion, it just observes it. Something to mull over the next time you're reading a headline and feeling that spike of adrenaline. Is that your feeling, or is it just the data points arranging themselves in your brain?
A question for another deep dive, perhaps.
Indeed. A huge thank you to the researchers Danas, Koya, Ekbal, and Banyopadhyay for this incredible work. And thank you to you for listening.
It's been a pleasure.
Until next time, keep diving deep.